So this example here wants us to find the corrosion rate, right? Wants us to find the corrosion rate in MMB and IPY, right? And it didn't state clearly whether one is penetration or not. And from what we've done, we already know that if the unit that we are supposed to use starts with a length one, then it's the penetration, right? So this here has inches at the beginning. So this clearly says that this is corrosion penetration rate, right? So this is corrosion penetration rate. And this one, because it starts with just mass, this is just corrosion rate, right? That's given us the current density, right? Okay. So we know that corrosion rate, general formula is current density, and then we have the atomic mass or molecular mass, and then we have number of electrons involved, Faraday's constant, right? And then the corrosion penetration rate is just the C, that the corrosion rate all over density, which is the same as current density, atomic mass, number of electrons, Faraday's constant, and then density, right? Okay. So the first one wants us to find the unit in mm. It's not always that the full meaning of the unit is given, as is here, milligrams per decimeter cube per day, right? Okay. So then with that, that will mean that whatever units, if you want to make your work easier, where you are not memorizing any table, to make your work easier, you just have to make sure that all the units they are using are in this unit. If it's length, if it's mass, it should be in milligrams. If it's length, it should be in decimeter, right? And if it's time, it should be in day. Okay. So then we know that there's current density here, right? And then it has a length, something concerning length, and that's centimeters, meaning you have to convert it, right? So some conversion has to be done concerning this, right? That's we are starting with A. And then for the molecular mass gram per mole, some conversion has to be done concerning it because it's given in grams per mole. We have to just change it to milligrams, right? Number of electrons is just number. Faraday's constant is usually in, let's see, Faraday's constant is usually in, we have coulomb per mole, right? But then that will mean, and it's the same as having a amperes second per mole, this per mole. That will mean I will have to change something as well to the seconds here to D, right? So that it matches what is there, so you can move directly to the answer that you're looking for, right? So meaning basically we are doing conversion for all of them. So let's see. So I mean that for A, the corrosion rate that we are looking for, the current density has been given. So we have 1.6, let's see. But if you have familiar or comfortable with memorizing the table, it's fine. That one should work as well. But then if you can go step by step, break everything down, you definitely know which one to convert, which one not to convert at every point in time. That's another way of doing it though. And not everything, not all the conversions are within the table, right? IPY like this is not in all of the table that I've seen. So the corrosion density is 1.6, right? 1.69 times 10 to the power minus 4, right? So this is in, what was the name? Amperes per centimeter cube, right? So that will mean you have to change the decimeter, right? Centimeter square, that will mean you have to change to decimeter, right? So I'm going to convert this straightforward. So let me put this here. So I know that the decimeter will be at the bottom, right? Centimeter is at the bottom, so if I'm changing it, so let's see. So centimeters squared is the same as 10 to the power minus 4 meters squared, right? And decimeter, so when 1 decimeter squared, so decimeter squared is the same as 10 to the power minus 2 meters squared, right? So that will mean that this that I'm trying to convert here will be equal to 10 to the power, because this is what I have, right? So 10 to the power minus 2, right? 10 to the power minus 2, and I have decimeter squared. So that's what we have. And for this one, it's just a matter of convention. No, that's if you can go by this one, then you can use it that way, right? So now I have 10 to the power minus 2, right? And it's in decimeter, so it's fine. So that will mean that I'm done for the I, right? The molecular mass, the molecular mass is generally given in grams per mole. That one is straightforward. It's just about converting it to milligrams, right? So let's see. Okay, so I have this, and because here the sample here is iron, right? Now we use the atomic mass for iron, which is let's see, generally it's 55.85, right? 55.85, right? Grams per mole. But what we are doing here, the computations here require that for us, because of the method we are using, requires us to have it in milligram, right? Milligram. Right. So if milligram, so let me write the unit just so it's clear. So this here is in gram mole, right? So if I want it in milligram, that means that I'm introducing 10 to the power minus 3 here, right? So that will mean I have to bring an additional 10 to the power 3 here, right? This, in the sense that will see that this one here is taking care of this one here. So in the end, it ends up being the same as 55.85 gram per mole, right? So I'm just bringing up the gram per mole there for us to see how it is. Right? I'm bringing the milligram as well. Right? So we've converted that as well. The number of electrons involved ion, that generally will be 2 electrons, right? And then we have Faraday's constant, right? Let's see. It's usually given, but I prefer using a calculator straightforward. Right? So let me see. Faraday's constant. There's an approximation, but I use the one that calculator to make my life easier. So this is Faraday's constant, right? You just have to know the unit to use, right? Okay. So this one here has been, as we said, it has been changed to decimeter. That's for this one has been changed to decimeter. Fine. That's the only thing, the current density that's not relating. That won't work well with this one, right? And then we have molecular mass. The only thing that to be changed will be the grams to milligram. That has been done as well. Number of electrons is straight. Faraday's constant has a second, right? Because Faraday's constant is E second, and then we have per mole, right? The only thing that has to be changed to make it fit will be the second, right? So yeah, that's the only thing we're doing now. So let's see. So this Faraday's constant, it has a second, which is a numerator, right? So let me write this here. So Faraday's constant unit is amperes per second, ampere second per mole. Right. So meaning that the second is a numerator, right? So if I'm trying to change it to what we have here, the time in the unit that we want is in days, right? So I mean I have to change it to day. And doing that, that will mean I have to do a division, right? Because I'm going from seconds is smaller than a day, right? So I have seconds to minutes to hours and then to day, right? So and a day is bigger than a second, right? So I mean I'll do a division. So that to make that easy, yes, that's what I'll do. That means that second, if I'm trying to change it to, we have second, and then we have minutes, and then we have hour, and then we have day, right? So to make my easier, I'll do this step by step, right? Changing second to minutes means I have to divide it by 60. So divide by 60. Now I have it in minutes. I'm changing the minute to hours, right? I'll divide by 60. I'm changing the hours to day. That means I'll divide by 24. Right? So that's how I'll do it here. So the same thing. Right, so there's the Faraday, right? So this one here is actually related to this unit that we have here. Right? Okay, so then that means that's 60 60. Let me make it down. That means 60 times 60 times 24. Right. So this is all I need to actually point and get the answer that I'm looking for directly. Right. So Faraday is here already in what we are doing. So let's see. Minutes. I just have to point these. Okay. So I have here I have 1.69 times 10 to the power 4, right? And then I'm adding all the conversions that I've done, right? 10 to the power minus 2. And then I have times 55, 55.85, and I have times 10 to the power 3, right? Everything added. At the bottom, I have 2, and I have Faraday's constant, and divided by something. So Faraday's constant will be the numerator. Constant Faraday. Let's see. Here's it. And then here I have 60 times 60 times 24. Right. So this is it. Okay, so it looks like there's something I've made. This is actually minus, right? Minus. Yeah. So minus, when we put it here, so when we put that, it gives us the answer we are looking for directly. So that's 422.60 to, let's do 40p, 28 mdd, which is milligrams per decimeter square per day. Right, so that's it. So basically that's it. If you're able to follow this through, you'll be able to get it directly. So this here gives us the corrosion rate, right? So this is the corrosion rate.